sir.
Sure, thanks very much. Good morning, colleagues in Europe and America. We have Jim Murphy from the Lawrence Berkeley Laboratory in Berkeley, California. He's actually a colleague of Jerry Jimenez, who will be speaking later on today. But we're looking at his facility, and he's been out there for about 28 years, and he's been describing to us the power supply, or the power source, I guess it would be the services to this particular facility. And so what's your incoming voltage here? You mentioned this is a 1200 amp service here, is that right?
Yeah, that's 1247. If you scroll more to the east, you'll see our main switch station or substation.
So let's see. So where am I? How am I doing here? So I see a number of transformers here. So how am I doing?
Right.
Where do I need to be?
Keep going a little bit more east, and you'll be there.
There it is, right there, right?
Yeah. So you see that what you see there, there's actually 2 yards. That green building, that green roof you see there, that is the UC Berkeley 115 kV to 1247 substation that feeds the campus.
Mm-hmm.
And we are right next to that.
Okay, so over here. So if I'm looking at it, is this your?
If you scroll
this
a little bit north
for Berkeley, UC Berkeley. It comes in at 115
yes.
from Pacific Gas and Electric.
Yes.
And then comes down and he supplies his. So I see these are 2 transformers. Is that all he's got there? Those look like.
That's all. Yeah, he's got 2 transformers, and he'll tell the size, but I think they're about 30 MVA transformers.
Okay.
And that little structure you're zooming in there now is the where their 115 kV SF6 breaker is.
Okay.
That's for their line 1. There, we have 2 lines coming into both us and campus. And you'll see right next, further over, you'll see their line 2 pad. But our system is just a little right next to this. They border the fence line's border. And
I see more gear over
here. We go.
Is this your gear also?
I'm not see where. Yeah. So you'll see here a lineup of 4 single-phase transformers. University of California and Department of Energy bought this substation from PG&E in, I believe, about the mid-90s, and then we remodeled it in early 2000s. And those 4 transformers was the old PG&E configuration where you had 3 single-phase and a spare.
Okay, so each of these are single-phase transformers here?
Yes.
Okay. Well, you have a fair amount of hardware spread out. It's not concentrated. What I'm seeing here is I'm seeing incoming over. I'm seeing basically this whole area here is just a lot of service switchgear and transformers and such. It's all concentrated in this area.
From that substation, which we call Grizzly Peak, we distribute out to 7 switching stations around the laboratory.
Okay, so you're referring to this laboratory here?
Yes, the Lawrence Berkeley Laboratory is approximately, I think, 200 acres with about 100 buildings on site.
Okay, all right.
So we're very concentrated.
Okay. Well, what I find interesting is do you have secondary then coming from? I guess I'm looking at considering the how much power you're running, but if you're coming in here on single phase and you're running, you say you were running what would amount to secondary over from this distance over to here. Is that what you're doing? It seems like a long secondary conductor. That's some serious
Yeah, we drop down to 1247 there, and we distribute 1247 around the laboratory.
Oh, okay, it's 1247. It's not 12. You said it's 1200 amps. 1200 amps, 1247?
Yes.
Okay, all right. Yeah, yeah, okay.
Double-ended redundant power.
Mhm. Okay. So this is all yours this is, you own this, you maintain this, huh?
Yes.
And who owns, with your arrangement with PG&E, I guess let's just look at this one here. Maybe you weren't around at this time, but the conductor, the primary conductor from wherever their source, assuming it's a tower somewhere, who owns that wire? Whose wire is that from their source to the primary terminals here? Whose wire is that?
Well, it's not showing up here on the map, but you see that the platform where I said that the campus, UC Berkeley's SF6 breaker sat out on that pad remote across the road from their building.
Right here?
Yes, that one there. Between that, there's another one just next to that, and between that is the PG&E tower. The utility tower sits between there.
Oh, and right here?
Yeah, you can barely make it out there, yeah.
Actually, I think we could probably get in, we could probably look at it from here. Let's see, let's look at that tower. We can get because it seems like a concentrated. I guess we can't. Okay. All right, that much said. So it's not a long wire, and I'm just curious. So, so you pick it off here, it comes to your breakers, and where does your maintenance responsibility become? Is this all your gear to maintain?
Well, this pad that you see there is actually Jerry Jimenez's group.
Yours is over here.
We have ours is the other structure where there's 4 single-phase transformers, and you can kind of see there's difference in color in the rock is the kind of the delineation line you see. Mm-hmm. So this is one set of transformers which we call our Bank 1, and then over next to the UC Berkeley we have our Bank 2, which we replaced a few years ago with a single 3-phase transformer. Mm-hmm. You kind of see it right there next to the Google on the bottom of your screen.
Part of the screen.
Okay.
Left, right.
So right in the bottom middle of the screen, that green building, and that dark gray area, that's all UC Berkeley's. Mm-hmm. The area to the top of the screen, where it's kind of more brown rock area, that belongs to the Lawrence Berkeley Laboratory. Okay.
So you've got a federally sponsored research lab integrated with your campus system, and it sounds like there's different management structures. You're managing something that's in proximity, but I guess economically and I guess electrically distinct. Do you ever, if there's ever a failure, are you guys ever porting power back and forth?
We can. We share the 2 incoming lines from the utility. Although the Lawrence Berkeley Laboratory, we are metered by the Western Area Power Authority, mm-hmm. where UC Berkeley has their meters or PG&E meters.
Okay. All right.
So we essentially buy our power from WAPA, and they buy theirs from PG&E, even it's the same lines, but we do have a pair of 1247 lines running between our 2 switching stations there on that corner, so we can feed power back and forth, but both facilities have grown to the point where that really doesn't help us much. Mm-hmm.
Yeah, then
because we were running about 12 megawatts total for our site, which seems very little. But we've just added a new building which has about 142,000 square feet under the roof, mm-hmm. and it's our high energy computing center. We've got several supercomputers in there, and So that building alone is designed to pull 17 megawatts.
Mhm.
And they're looking at increasing it to 25 megawatts here in the next few years. So we're doubling and possibly tripling the size of the demand on our system in the next 5 to 10 years.
What kind of demand factor? So when I ask you questions, then I guess I'll ask them more having to do with the lab and the maintenance. You mentioned the maintenance, of course. I don't have to tell you, maintenance is a key component of reliability, and we probably have the first name in reliability on the phone right now, or on this call right now, but he's not able to. He probably doesn't have a microphone on this. Bobby, you're able to talk at all?
I am. I'm able to talk here.
Oh, okay. Um, so I guess I always focus when Robert's on the phone. I'm always trying to ask questions about maintenance, preventive maintenance. And of course, some questions would come about regarding your failure rate, your availability. Bob, do you have any questions about that?
Well, it seems like he has a pretty redundant system with dual feeds coming from the utility, and it looks like that he's got a. I'm just curious about the single transformers, the single phase transformers, and your three phase, and why the difference between the two.
I'm having a hard time hearing him.
Are you having a hard time hearing him? His questions were about the bank of single phase here. One of them is redundant, or it's a spare, so to say. And Bob, could you repeat the question to me, and then I can repeat it back to Jim?
Okay, so I was curious about the difference between the single phase transformers and one substation and the three phase single transformer in the other substation.
So Jim, Bob was asking about the difference in the bank of three single phase and then the three phase transformer on the other. On the other, you mean on the Livermore campus, or the other three phase? You have Jim. You have one three phase bank here, right?
Correct.
Okay, and that's somewhere in here, right? Is that still?
No, it's right there.
Yeah. Okay. So that's what. Tell him a little bit more about. I guess that you're concerned about phase relationships. How you if you are they set up as redundant? I mean, go ahead, Jim. You want to talk about that? I think I know where he's going with it.
You want me to explain now?
Yeah.
Okay. I just didn't want to talk over Bob. So when we purchased, or when PG&E, Pacific Gas and Electric Company, owned this substation, we had two banks, and each bank had 4 transformers in it. Here, about 6 years ago, we were noticing that on our oil tests that we do annually on our oil-filled transformers, the tests were starting to degrade. That was showing degradation in the bank 2 transformers. So we opted to replace it, and when we replaced it, we replaced it with a single 3-phase transformer. We do run the system in parallel. We are tied at the 115 kV level, but the 2 banks are separate at the 1247.
Yeah, it's probably easier to see on one line. You're saying you're running these 3 and this one in parallel.
In parallel on the primary.
Yeah. Okay.
So we can tie at the secondary, and when we purchased the 3-phase transformer from Delta Star, one of the things is we wanted to match the impedance of the other bank, the 3 single-phase transformers, so that we can tie, but we don't run with the 1247 tiebreaker closed. It's only we use an automatic transfer switch system where we have a closed transition, and it's only tied for 6 to 8 seconds when we do that. We just completed yesterday a 4-week maintenance on that 115 kV yard prior to this maintenance, we were always able to move our load over to UC Berkeley on those two 1247 tie lines we have between us and their Hillside substation there. But since our load has increased, and because of some configuration issues Jerry's having on campus, we couldn't do that this time. So this is the first time in probably 15 years that we've had to do maintenance in there while leaving one side energized and have the other side de-energized, which created some safety issues for us with having lifts and workers up on the towers testing and cleaning insulators and open air switches. So we just completed that maintenance, and we try to do that maintenance every 3 years on our system.
Robert, any thoughts? I have some questions, but you're yours first. You're the reliability guy.
No, I don't have any thoughts at all. He explained the difference. It sounds like it's an economical decision to go to a single three-phase versus the single-phase transformers. He's doing more maintenance than the majority of the people that I know of, anyways, that does those maintenance. So I don't have any questions. It sounds like it's been a pretty smoothly run organization.
Yeah, it strikes me. Yeah, it strikes me. Oh, let me back up again. So when you're running open, you have what is essentially main time main switchgear at the secondary side. Is that right?
Correct.
But on one bus you've got the 3 single phase, and on the other bus you've got the 1 3 phase. So who equalizes voltage? Is that something that you have the utility come by? I mean, I'm assuming you have precautions for circulating current when you close the tie. Who does that who does that work? The utility, or are your guys trained to do that?
Well, we have parameters that we can switch under, but one of the things, the voltage, we have the incoming on the 115 kV level is also main tie main, but in that configuration the tie is closed at all times, so our 2 incoming lines and the primary to the 2 transformers are tied together.
Okay.
So we don't have a incoming voltage variation, and the voltage between the 2 banks is, I haven't looked at it with any kind of a accurate, depending on the accuracy of the meter, but it is very close on the incoming.
Okay.
We have not had any problem. Our current, that's why one reason we limit the amount of time we're tied at the 1247 on the secondary side.
So if I come to understand this better, is that just for legacy, because of historical reasons, so I'm assuming the 3 single phase bank were the older system, and the 1 3 phase is the newer system. Is that right?
That's right.
Okay. So that was probably done for economic reasons,
Correct. We were looking at the losses in 3 single phase transformers compared to 1 3 phase transformer.
Could you refresh my memory on that? So you have which gives you more losses, the single phase bank or the 3 phase bank?
That was what our energy efficiency people were concerned with, was that we had increased losses with 3 individual transformers compared to one single 3-phase transformer.
I would say
the way this come about, it was on an airplane ride to Washington, D.C. with our laboratory director, which eventually became Secretary of Energy Stephen Chu. Had a conversation with what I believe the story went with the president of Siemens, who was concerned that why we were doing something that was outdated by putting individual single-phase transformers back in, because we were right in the design phase of replacing that Bank 2 transformers, and that plan was to go back with 4 single-phase transformers again, until our director was on this plane ride with the president of Siemens, and the plan changed to a single 3-phase transformer. So I don't know if there was too much engineering involved more than just politics.
Bob, what's more reliable? What does your data show? Oh, Jim, by the way, Bob's the chairman of the IEEE reliability book suite. And what do your numbers tell you, Robert? Bob, is the I guess intuitively I can see trade-offs with availability on the single phase bank versus the three-phase bank. But then of course there's efficiency reasons. Could you tell us a little something about your how you look at this from a reliability standpoint, Bob?
Well, I would say that the bank of single phase transformers would give you a lower reliability because you're looking at a much larger infrastructure that you have to take into consideration, which is the cables and the connections and everything else that's going on. But I also would think that the three-phase, number one, would give you a little bit higher availability number, reliability number, but your efficiency should be much higher in a single three-phase than it would be in an individual single-phase transformers. That would be my gut feeling without looking at the the exact load characteristics. That would be my gut feeling.
Is anybody installing single phase banks anymore?
I haven't seen one yet.
I'm just wondering if the case in industry. I mean, I see the failure mode for us has been a failure of a winding, or actually no. I think we see our instrumentation transformers, the PTs and the CTs. Typically, the PTs fail. It's not been a winding. I have seen some catastrophic utility level transformer failures, but they were not. But they weren't single phase banks. I guess instinctively, I'm thinking if he's got an extra single phase bank there, he can roll it in relatively quickly and restore to normal. But that's just me. I'm not.
And I would think it would be an economical thing that single phase transformer versus a three-phase transformer. I would think that would be economic in nature. And, Mike, I have seen some warping of the cores due to power quality stuff. Some things like actually I've seen them where there's been an arc during the switching process. I've also seen lightning strikes in the utility system that would causes overloads in the core and can warp them.
Mm-hmm. So, in your mind's eye, Jim, would you visualize getting this three single phase bank out or four single phase bank out and replacing it with a newer three phase bank?
Those transformers were replaced in about 2001 when we remodeled or refurbished this yard after just before DOE basically took it over. The yard that is ours was the original PG&E yard, and it fed both UC Berkeley and the Lawrence Berkeley Laboratory. After PG&E divested and sold off a lot of this stuff, UC and DOE purchased it, and then about 5 to 6 years later, UC Berkeley built the substation you see there in the lower part of the screen, and they call that Hill Area Sub. And after they built that, they were able to use our 1247 tie line that we have between the two and feed the laboratory while we remodeled the Grizzly Peak area, which was the original. At that time, we replaced those 4 single-phase transformers with new Waukesha transformers because they were the oldest. They were from the mid-50s. So we were running 2 banks of 4 single-phase transformers. So there's no need. The transformers are still operating well. We've checked the oil samples annually, and we're not seeing any degradation in any of the windings in the oil or seeing any gases in there. But there is an issue right now with the laboratory is looking that in 2020 we're going to run out of capacity. So one of the thoughts is to replace those 4 single-phase transformers with 2 3-phase. So we'd end up with 3 banks and be able to increase our available energy there on site.
So when you say demand, is that a peak? I guess I should, I've heard these arguments.
Well,
what is
we can run 41 megawatts right now, or 41 MVA is what our system is designed for.
Okay, all right.
Our transformers are 30, 40, 50 MVA.
Mm-hmm.
So we have a couple of designs that we've been looking at. Is the limitation is what we call our switch station 1, which is right there, right next to the 115 kV yard, and it's limited by the 41 MVA.
Mm-hmm.
So there's thought to put another switch station in the area, run the transformers in there, and then feed back out of there to additional switching station to try to increase our capability.
So you plan for full redundancy on one end, right? Peak demand.
That is the current design that we have at the laboratory is 100% redundancy on the high voltage, medium voltage distribution system.
Since it is a laboratory, how much control do you have over peak demand compared with, say, a campus demand? It seems to me you may have. I respect research priorities and such and so forth, but since you're dealing with a laboratory which has a certain kind of risk profile, I'm not sure if you're renting out space to other researchers. What does a demand factor look like for you guys, and how much control over do you have over that, over the demand?
We have no control.
Okay.
That's why we have so much capacity built in, I guess, or excess capacity built in currently. Because, like I said, we ran 12 megawatts was our typical load on the system at any time on a summer day, which it doesn't get too hot in Berkeley. So, and we had a system that could provide, I think it was 41 megawatts actually. So we didn't care what anybody turned on or what they ran or when they ran it. And we don't we don't have a power factor demand issue on our utility bill. Basically, they're not paying for it. Our laboratory is not concerned with if our power factor's down in the low 90s.
So, as a national lab, then what I fully understand now is that you have a different type of occupancy. It's probably largely you consider industrial, probably a lot of administrative space, but it's I guess I'd call special purpose type of occupancy. So, a lot of the energy regulations that come out for building for Jerry's campus, for example, likely don't apply to you. I do have a time limit here, and I just one question I had, and it feeds into what the discussion is with Jerry. What was of particular interest with Jerry's system, and it had to do with whether or not your utility allows you to place resistors on the secondary side, on the 1247 level, on the secondary side of your service, so that you can impedance ground your secondary system, which amounts to your medium voltage system. Are you solidly grounded at the National Lab here, or are you resistance grounded also?
The 1247 is solid ground.
Okay.
We are running resistive ground on the 115.
Okay, so you started from scratch as resisted grounded. Excuse me, was the resistive grounding the first system?
In what respect?
Which system went in first?
I think we inherited the resistive grounding from the utility.
Okay, that's exactly what I suspected. So when the National Electrical and the culture of the industry uh, settled on solid grounding for building premises, then the type of engineer that you would get to do that kind of work was not a utility level engineer. And it's not one who's generally comfortable with placing resistors on medium voltage systems. That's my thesis about the utilities have been generally comfortable with resistance grounding for a number of reasons, but a utility engineer is a different type of guy or a different skill set than an engineer who's in the service of an architect who wants them to slam in plugs and lights.
Yes, I've run into that also when we started losing some of our more senior engineers to retirement, and we started looking for the replacement power engineer. There wasn't a large pool to pull from that were looking for jobs. If you had a job in that area, most of them were staying where they were because the organization wanted to make sure they kept them.
Yeah. Okay. Well, so that's why my agenda. If you go back to my CV, you'll see that over the years, I've been on the NEC since '96, and I've been at U of M. I was at U of M for 34 years. I struggled with this. We had all of these safety parameter imperatives. How can we make it safer for our electricians, particularly the ones working at the medium voltage level? So it's pretty clear what we can do, but I would run into the legacy solidly grounded system, and seemed like 2 or 3 times a year I run into a situation. I'm thinking, darn, we have to work on this hot. I wish I could protect my guys, at least expose them to less fault current. And that wasn't a choice for me. I inherited the system, and there wasn't. In the case of Detroit Edison, they were not receptive to placing resistors on the secondary side. I've since learned, largely from Jerry and from David Shipp at Eaton, and a few other people around, but it's utility dependent. Have you run into that before, Bob? That utilities tend to be the ones who will prohibit the application of resistors on the secondary side of their services?
Yeah, we run into that all the time. That's absolutely true.
Yeah.
Especially with the older systems that we run into on the different bases, the Army forts, we run into that situation all the time.
Yeah. So I guess to start to close this out, that's the bridge I wanted to build between the time you spent with us, Jim, and why we're putting Jerry's system in the spotlight. And now I've learned that you also have a resistive grounded system. And as someone who works on the National Electrical Safety Code, which just came out again, and one who works on the NEC, we don't have a technical problem with it, apart from what the utilities subtransmission and transmission distribution requirements are. It's largely a cultural one, and one in which we say if we're serious about wanting to protect our medium voltage electricians, and I'm assuming that they're a different a trade class, Jim, in your area. Is that fair? You have to train those guys differently than your guys that are changing ballasts. Is that right?
We do. Unfortunately, our workload is not such that they only work on the high voltage all the time. They are a combination of what we call our 600 volt electricians and our high voltage electricians. So they do 600 volt work primarily during their normal day, but when we have to do switching or any other kind of repairs, we have to pull we pull those few guys off the crew to come do this work. If we get into a lot of our repairs of equipment or large cable pulls, we'll contract out with an outside contractor.
Okay. All right.
Just this last maintenance, we brought Emerson Electrical Reliability in to do the maintenance in the 115 kV yard. A few months ago, we had a maintenance in one of our distribution switching stations and several buildings at the same time, and Eaton was the contractor for that.
Okay. Yeah, they're generally a very capable group. Eaton, I like to point out, has been a supporter for our project to try to get the sizes of internal building power systems right sized. But it's a long, complicated discussion. Jim, you've been very generous with your time. Is there anything that I can say, or Robert can say about what if you had to go to upper management and say, I need money to do this right, where would be your top 1 or 2 priorities? If you ever needed a colleague to endorse some of your thinking, where could we help you?
Well, I think we're facing the same thing you were talking about, is worker protection while being exposed to the energized systems. I mean, arc flash is the big thing right now. It has been for many years, but I think we're starting to refine it. And since we are a national laboratory, we are held by law to enforce NFPA 70E. That was it came out of Congress in 10 CFR 851 that the national labs will comply with NFPA 70E. So, arc flash studies and trying to figure out ways to protect our workers is one of the main focuses for the electrical engineering group right now.
Is there so, as somebody who sat on that committee, we are always saying your first choice is to simply take the power off.
Correct.
We put the word likely to be energized. The word likely, we argued back and forth quite a bit. I cast the deciding vote, and that's a longer discussion. So about why I did that.
Mike, it's not that easy to turn the power off. I work for so many different areas that literally the power cannot be turned off because of the importance of the mission. So that's a major issue.
Mm-hmm. Yeah, I get that. I know that, but I always am obligated to say to remind people that's your first choice, and that's where you're supposed to go first. 70E says that. So that much said, and of course, when you're phasing equipment, you have to work on it energized and such and so forth. So, okay. Well, Jim, we could talk a long time. I'd like to help you convince your boss that they're doing it such and such a way at U of M. What do we have? I think we'll be having, we had MIT on here a few weeks ago, and they gave us, we have kind of the same lament. You're just trying to get by. You're getting numbers about demand. It's a type of technology that requires a fair amount of planning ahead of time. But we're grateful for your time here, Jim, and we hope possibly you can come in and chime in on Jerry's presentation. I like it when we do it this way. It's not polished, but as always, as you can see we have several hundred YouTube videos. We have made the choice to deal with unedited information and simply get it out there rather than spend more resources than we have fluffing it up. There are some video recordings where we have polished them a little bit, but it's more important for people to speak from the gut. And as you can see, and extemporaneously also, very often you get more. And there's not so many of us out there that, and the people who understand what we do, that we actually required to to polish our work. So this will be uploaded onto the web page for others to see. I'm sure they'll be enlightened by it. And so for the moment, that's a full hour, and pretty much a full hour. I regret some of the technical problems we're having with sound, but it looks like they cleared themselves up. Anything else, Jim or Bob, that I can do for you?
No, been fine so far.
Okay, so just a couple reminders here is that there is we have the meeting in Portland. Jim, if you need me to tell your boss that you need to go there, I'll certainly say say there'll be a big meeting of all the large research university campus power guys, and you'll help me with that one, right, Bob? And then and then of course, so that's in Portland in a couple weeks. There's one. This is the education committee. We'll be meeting there on site at regular time, or the assigned time. So the time frame for that, we're going to try to put that one in teleconference. Also, we'll be trying to make some progress on the campus power distribution standard. There is and then this is for our colleagues in Europe. The Europeans are also running into some of the geometry of how, in fact, I tried to say that in here, the geometry of how information is being transmitted within large, complicated within stakeholders in the process is it seems raised the level of debate, at least among the regulators. But as typical, the technical people are not as involved. So you can see some of these standards organizations are trying to change the orientation of how information is transmitted through their standard suite. So, and I guess that's it. There's a workshop in San Antonio, but we'll be here again today at 3 o'clock, and then we'll be at the IAS conference on October 3rd. So with that, guys, thanks very much for your time, and we'll see you on the Worldwide Intertubes.
Thank you, Mike. It's good meeting you today.
My pleasure. Take care.
Take care.
Bye, Bob.
Bye-bye.